Let's constrain and route some DDR3 memory. In product settings, we choose a high-speed license, and then we're ready to constrain our critical differential pairs. We'll assign a differential pair rule stack to the differential clock. The rule stack for the DDR3 clock yields a differential impedance of 100 ohm. We calculated those automatically directly in eCADStar, but you can add your own values if you prefer. We constrain timing and length relationships by creating skew groups. In this case, that's DDR3 clock relative to strobe. You get better signal integrity with laser drilled microvires. We set that up in the design rules in the library. We set up all those constraints and rules in the front end and the library, so let's bring our work into the PCB design and get routing. There's the same constraint browser in PCB editor as there was in the front end, so we can navigate the design and set constraints in exactly the same way. High-speed signals need a high-speed topology, and this address command signal has to be routed to a flyby topology. We select the topologies we want from the standard and supplied topology templates and apply them to the DDR3 signals. Right now we can see we're not meeting those clock to strobe length constraints. Let's fix that. First we lengthen the DQS strobe. We get full control of the lengthening pattern and a lot of real-time feedback on how we're doing against constraints. Then we check back in Constraint Browser to make sure those red constraint fails have gone. Now for the differential clock. That's got relative length constraints not only against the strobes but against the address command bus. We can see in real time how close we are to all of those constraints, even as we change the lengthening style and adjust the pattern by dragging the handles. Now we've routed those DDR3 signals to constraints, we'll just do a final DRC check. And finally, there's no substitute for 3D for making sure everything's as it should be, and we've optimized our PCB for high speed.